Commission. As I'd like to welcome you today for our second series of webinars. This webinar is offered by the Canadian Honey Council in cooperation with the tech transfer team across Canada, and in support and with support from Véto Pharma. They offer us their platform in our seminars, so that really helps us to spread the word about bee health across the continent, and hopefully that will help everybody to benefit from the information shared with you. Our seminar series, we call it Canadian Honeybee Health webinars. And for this series, we are talking about adaptive management to keep honeybee healthy. We had good turnout last webinar, and we hope this webinar we have the same kind of turnout. And for today, we are going to have two speakers. The first speaker is going to talk about forecast beekeeping management adaptation, and that will be presented by Dr. Manuel Hempel. And I would like him to introduce himself to you and start his slides. Thank you.
Okay, thank you. I will just
One thing before we go, if you have any question during the presentation, please write it down in the Q&A. Sorry, not in the Q&A, it is on the chat. So that will be easy to follow the questions. And be aware, at the end of the presentation of the two speakers, we have about 30 to 40 minutes for Q&A in person. If you have questions, also put it in the chat so we make sure we answer all the questions needed. The webinar is going to be recorded, and the recording will be available to the people who signed up for the webinar to review some other time. Thanks again, and go ahead, Manuel.
Yes, thanks a lot for the introduction. So my name is Manuel Hempel. I'm from Norway, and I work for Norse Research in the Climate and Environment Department, mainly with climate risk in agriculture and food production. And I also am a beekeeper, so I managed to pull the beekeeping a bit into my main job, and I've been working quite a bit here with pollination, climate adaptation, and climate risk in beekeeping practices. So I'm a local beekeeper in town, and it's a relatively small scale operation compared to North American standards. So I have about 40 beehives right now, spread around in town in different locations. So I have a lot of small beehives, for example, that I run for hotels or restaurants where all of the honey from a certain beehive goes straight to them. So that's the model. Yeah, so it's relatively small scale with a lot of beehives spread out. And in the bottom left, you can see the city of Bergen and some beehives up on the mountain above the city. And that's where I'm sitting right now. So just to give you a reference for where we are, the city of Bergen is at about 60 degrees north. So we're basically more north than the southern tip of Greenland. And also, if you look to North America at 60 degrees, I don't think there's a lot happening there, especially not with agriculture. But on our side of the Atlantic, we have the Gulf Stream, and that keeps the entire Norwegian coast ice-free all the way into the Arctic all season around. So we can actually do some forms of agriculture quite far up into the Arctic. So I know some beehives that are not too far from the North Cape above the Arctic Circle, and there's some people doing beekeeping up there. And when you zoom a bit in, you can see this red square on the bottom left, and basically this is my region in Norway. And then if you look on the right side, you get an idea for basically the topography and the geography of what I'm dealing with and where we are keeping our bees in the region. So you can see it's a very rough terrain. You have a lot of these deep fjords that cut into the country. You have a lot of these mountain ranges, glaciers, and the area itself is not so very well suited for a lot of forms of agriculture, actually. So most of the honey the beekeepers produce here is based on wildflowers and wild forage, and probably similar stuff than the things you have in Canada as well. So fireweed, for example, is one of the main flows, and the main honey flow in Norway. So that what gives you probably what produces 80% of the honey here is the wild raspberry that we see on the right side. So these wild raspberries, they bloom for quite a long time, and they also produce a quite good amount of nectar. So basically, I would say that 70% of the Norwegian honey production probably depends on the wild raspberries for the summer honey production. And our season here goes quite long. It's a late start, but it extends all the way until maybe early September, because in late September we have heathlands out on the islands. So after the main flow of the raspberry, we move the hives out to these islands for the heather flow. And that's also very typical Nordic or Norwegian honey. And then you can see a lot of the migratory beekeepers moving their beehives into the landscape we see on the left here, and space them around there. And yeah, so that's basically the wild forage. And as I said, it's not very suitable for agriculture in my region, except for fruit production. So within the fjords, if you go a bit more in, you can see there's a certain degree of fruit and berry production happening in these fjords, and you can also see a lot of dandelions blooming within these apple orchards. And that's basically the main crop we can produce in this area. And as beekeepers from the Bergen region, we move our hives in for pollination for the blooming period in May. So now from mid-April, we will start preparing the hives. So the season here didn't start yet. And then we will move the hives into these apple orchards by early May, I would say. And yeah, basically this is how the landscape looks like. And then these hives are distributed around all of these different apple orchards in this landscape. Usually starts with plums. Then we have the plums, the cherries, the apples, raspberries, and yeah, that's mainly it. Some pear production as well. And yeah, so it's the geography that is a bit challenging for us, but the thing that is the most challenging for us in our region is actually climate and weather related aspects. So I just wanted to show you the amount of rainfall that we have here during the year. So here we have the entire year, and we can see the amount of rainfall on millimeters on the left, and all of the blue stripes are basically a rainy day. And in our region, we have about 260 rainy days a year. And on the right side, you can see it accumulates up to about 2,500 millimeters. So that's 2.5 meters of rain that we get in this region every year, which is quite challenging if you're a beekeeper, because you always have to plan around it. And if you look at this graph, for example, like our main flow and main honey was produced in this little gap down here between May and June. And that was a little dry period. And then in a few days between June and July, and then it basically rained through the entire fall. So for us, these climate issues are a very big issue to deal with. And to just give you an introduction of, because I also work with in my normal job, work with climate adaptation with farmers. And then I often like to start with this image from the Apollo mission. Because if you look at it, you get the impression like, wow, the Earth is gigantic and our atmosphere is gigantic. But if you actually look at this from the side, you can see that the atmosphere is quite a thin layer around our globe. And sometimes if you ask people, okay, if you scale down the planet to the size of a football, what you think how thick that atmosphere would be. So you can think for yourself what you would guess how thick the atmosphere would be. But if you scale down the Earth to a football, the atmosphere would not be thicker than about 0.3 millimeters. So it's nothing. It's a very thin layer. And that means it's people kind of overestimate the size of the atmosphere and how big it actually is. And if you just take out the Earth of that and look at our planet without the Earth, this is basically atmosphere in scale. So this is basically this layer that's keeping us apart. And we have to remember that within this atmosphere, we have less than 1% greenhouse gases. Without these greenhouse gases, the temperature would be 33 degrees lower than what it already is, because there are a lot of people that might think the atmosphere is huge. If we blast out CO2 and other gases into the atmosphere, it's not going to have a huge impact. But then you have to keep in mind that less than 1% creates a temperature increase by 33 degrees. So it is very sensitive to the amount of greenhouse gases in the atmosphere. But we've been blowing out about 37 billion tons per year. And in the bottom left, you could see like how big is a ton of CO2. And so that's why the amount of CO2 has been increasing consistently. And with the amount of increasing CO2, basically also the temperature went up by quite a lot since basically the midway of the last century. And it goes quite fast. If you look at this now, you might think, okay, this is not a very steep decline in temperature increase, but if you look at it in a global scale and looking maybe 20,000 years back, then this is where we are right now. So this is basically the temperature increase or the temperature variation now over the last 20,000 years. And we can see now over the last 50 years, it's been going extremely fast. And all of this variation we can see on the left side in the blue lane, that can be explained with different phenomena called the Milankovitch cycle. So if we take these into the models, we can totally represent this. But the spike on the right side is, you cannot like recreate that without the big emission of greenhouse gases. And what is significant with this is like, because sometimes people say, well, the climate has always been changing. So why does it matter? We will deal. Well, we didn't really start producing food and agriculture before 10,000 years. So this is the safe corridor that we know we can produce food in and we can do agriculture in. And now at most of the places, we have already left this safe corridor. And the result of that is that by 2050, we expect the yield potential to go down in a lot of places by about 25%. So just to keep the amount of food production the same that we're doing today, we would have to increase the productivity by 25% just to keep up with what is going on. And this does not only affect like the normal agriculture. In Europe, we already see a lot of impacts of these climate changes on beekeeping operations. So in France, it happened a couple of times that there were catastrophic harvests, either due to very dry summers or to very wet summers. The same is happening in Germany. And I talked to a lot of beekeepers in Greece or in southern France. And for a lot of them, this is really an existential risk because they say we cannot plan on a normal season anymore. We cannot rely on a certain amount of honey coming in anymore that will give us enough income to actually run of this operation. And we don't have a buffer to go through a lot of bad seasons. And another issue is that spring is coming earlier and earlier, and the bees and the bloom are getting more and more out of sync in a way. So sometimes we had the problem here that we have a particularly early spring and the bees aren't ready yet. So they did not build up the strength to do the pollination job, or the spring comes early, the flowers start to bloom, and then the temperature drops again and the bees cannot fly. So we had cases here with some catastrophic harvests due to very early springs and very bad pollination conditions. And we can also see that this bloom is starting earlier and earlier in the year because some of the oldest climatological data sets we have is actually the peak cherry bloom in Japan. And here you can see when the cherries have been blooming in Tokyo, the last 1,000 years, basically. They have very good data about this. And then if you just look at the last 50 years, you can see that this peak cherry bloom is happening earlier and earlier and earlier in the year. So it's been quite stable for a long time, and now we see this drop. And that's exactly the problem we see in many parts of the world with early frost in the bloom. Problem for the beekeepers, problem for the crop producers. And in Norway, just 2 years ago, basically, of all the plum harvest, 90% was lost. So there were 90% losses because of an early spring. And then there's a higher risk of frost. And then the cold temperatures came back and there was frost damage. And there's no way to recover from that because the pollination sets the baseline for the outcome of the entire season. So what we've been doing in the climate department, we've been looking at these projections, but not only looking at the normal parameters like temperature or precipitation, how that will develop over the next years. But we've also been looking at some bee-specific parameters. For example, um, how will the growing season change? How many days will we have below zero in wintertime? So we could see like the growing season here on the top left, we can see it's coming earlier and earlier. At the same time, we're seeing that we're losing a lot of like cold days in winter. And at the same time, the flying days for the bees, like the conditions where they can actually fly, is not changing that much. So we have a longer season. So in theory, they could fly more, but we also have more rainfall. So that cancels out for the longer season. So even though it's getting warmer and the season is longer, the bees do not necessarily have more flight days in our region. And what we can see in the bottom right, that's basically just standard deviation for rainfall. And this just shows us that the variability is getting bigger and bigger. So it's going to get harder to predict. And basically the changes that we're seeing in Norway are getting bigger and bigger from day to day. So you can think, what's the impact of this on beekeeping, and why does it matter for us? Well, I cannot go through it all, and you probably most of you already notice when you work with bees in some form of agriculture. Like these earlier springs, they increase the risk for frost during bloom, and the bees and the blooms are a bit more out of sync. And if we have shorter and milder winters, that's a problem for our varroa management. So here in Norway, we still have some areas up north that are varroa free, and we have a very long winter. That's our friend fighting the mites, because basically there is no brood activity from October until April, and we managed to get away with one oxalic acid dribble in wintertime, and that's it. We don't do anything else, and that so far is enough to keep the mites in check. And our average losses in Norway are around 5%. Yeah, so these shorter, milder winters are a problem. Warmer and wetter, and we have higher risk for droughts like poor pollen and nectar supply. And we have basically this greater variability that makes it harder to predict the weather. And that's basically what I'm working with now. We are working with forecasts. So today we already have a lot of forecasts for the next 10 days, but often that's not enough. And then there are these climate projections from 10 days to, I don't know, 100 years in time, but that probably doesn't impact your beekeeping operation a lot. It will sometime in the future, but if you have to make decisions today in your beekeeping operations, they don't really depend on how the weather will be in 15 years. You're interested now in an area, maybe for the next 2 to 6 weeks, or maybe for the next months, or maybe for the next 10 years, if you're considering investing in some infrastructure that needs to get written off and paid down over the next 10 years. And yeah, so basically what we're doing is we're running these global models, which is basically the idea is we just split up the entire Earth in these little cubicles. And it is a physical system. Like the principle is relatively easy. So we have these physical equations. So if we know how the temperature, the pressure, the humidity, the wind speed, all of that is in one cube right now, we can calculate how that affects the neighboring cubes. And then we can just calculate up in time. And that's basically what these climate models do. The problem with this is that it's a chaotic system. So if you have tiny changes in the starting conditions, that will have huge changes long down in the future. So that's why if you look at the bottom right here, at the beginning, all of the results are quite tied together. That's why we can make good predictions for the weather for 10 days. But then longer in the future, we cannot really say anymore if we will be down there at the bottom somewhere, or will we be down there at the upper edge of the curve. So what we do is we run hundreds of these simulations to look at what are all the possibilities, what could happen. And we don't know which one of these exactly is correct or not correct, but it's not that important. So basically, I just wanted to show you what we actually do. So here, for example, we have possible temperature lines for 1 month ahead of time. So all of this could happen. We don't know what's going to happen. And we can see, like, at the beginning, we have a very small uncertainty. So we know we can predict it until then, but later we don't really know what's going to happen. So what we do is basically we can make a weather forecast for these first 10 days because we kind of know where we will be. And but if we want to see further ahead in time, we just look at the distribution of all of the possibilities. So we can see, okay, in 15% of the cases, we're somewhere in the upper end. In 75% of the cases, we're somewhere in the middle. And in 10% of the cases, we're somewhere at the bottom. And then we look at what is normal. And then we can give you a percentage and saying, okay, we have a 90% chance that it will be warmer than normal, or a 10% chance that it will be colder than normal. And that we turn it into maps that then look like this. So it's not so important that you look at all of the numbers here. So this is basically a 4-week forecast for Norway. I just wanted to show you the type of information that we're making and that we make available to beekeepers and agriculture is the probability for the next weeks that it will be quite warm or quite cold, and we can do the same with rainfall. And as I said before, we cannot tell you exactly how the weather will be, but we can give you the probability how it will be. So what it actually means is each map represents a pot. Like if a red ball means warmer weather and a blue ball means colder weather, we can basically calculate what pot nature is pulling this weather from. So if you look at week 2, for example, and you would have to make decisions that are weather dependent, you don't know how the weather will be now, 2 weeks ahead in time, but here you know there's a 90% chance that it will be warm. It could still happen that it gets colder, but if you follow this forecast every time from year to year, you will win more often than you lose. It's like counting cards in the casino. So we cannot guarantee the outcome for one single event, but if you keep on using this, you will win more often than you lose. So this is that's the difference between normal weather forecasts that are deterministic, where we can tell you next week it's going to be 10 degrees and rainy, to these probabilistic forecasts where we can tell you 3 weeks ahead of time, there's an 80% chance that it will be really cold here. So that's the kind of information that we are providing. And so since we're developing this, then we had a project to figure out, okay, how can we use this in beekeeping? So we worked closely together with beekeepers and fruit growers to investigate how this kind of information is used in real life beekeeping practices and in real life fruit production. And we provided basically the beekeepers with all of these forecasts through an entire year. And we had monthly meetings with the beekeepers to figure out, okay, what do they actually use this kind of information for? What is this good for? Does it help them to manage uncertainty and look a bit ahead in time, longer than these normal 10-day forecasts that you get? So just to show you some things that came out of this is just many decisions in beekeeping have a time horizon that is more than 10 days. And yeah, so you have to make do a decision now, and it doesn't only depend on the weather, how it is now, but like the next 3 weeks will influence if this was a good idea or not. For example, if you choose your forage region. But most people agree that the weather is more and more unstable, but the beekeepers turned out to be really eager to adapt. And the forecast we provided, they could successfully show that there was an early spring or a cold spell 2 or 3 weeks ahead of time. And then people use this for pollination events to anticipate when is the bloom going to start, to figure out should there be some stimulus feeding. Some people have remote hives, so then they can use this information to make an estimation how much nectar and honey to expect, so they can add on supers in time, so they don't have to do 2 tours or come back a week later to add more. Or also expecting the winter in time to start with your winter preparations. Or in Norway, one thing that is also very relevant is basically to figure out where to go, because I showed you these heather fields from the islands before, and some beekeepers can choose, am I taking the bees up into the mountains or down to the coast? and they put them usually there for a whole month. So then it's a very good idea to know how the weather will be for the next 3 weeks ahead of time. And that's exactly what you can get with the kind of forecasts we're producing. So basically, they used it for when to start the season, when to feed, prepare the pollination. It was helpful for queen breeding activities, choosing your foraging areas, to check, okay, do we expect them to run out of food? Shall we feed them now or not? And it basically saves you time if you're a bit more ahead of the weather rather than being reactive and always following the weather. Yeah, so basically to sum that up, it's the climate is changing a lot, and beekeeping is very sensitive to these changes that are coming. And these extended range forecasts that we're producing, they have a very promising skill and turned out to be a very helpful tool for the beekeepers. And as some of them said, we still don't know how it will be. We're still betting on the weather. But with these forecasts, the odds are stacked in our favor. So it's not only 50-50 anymore. And yeah, just to show you some maps at the end that we made here for North America. So this is basically for the running week. We're in week 13 right now, and for the next 2 weeks after. And this is basically the kind of information you could provide with a certain probability that it will be quite warm or cold. So now, for example, for the next 2 weeks, there's a very high chance, about 80 to 90%, that it will be relatively warm and mild in big parts of the US. And you can see up here in the northern parts of Canada, there's a very high chance that it will be colder than normal at this time of the year. So basically, the main thing I wanted to show you today is basically that these kind of forecasts exist. And if you're struggling with climate variability and think that better climate information is something that could be useful for your operations, this is something that is out there and that can be used. And that's basically what I wanted to show you today, and just to give you a short overview over what we've been working on and what we're trying to do with these forecasts for beekeeping and food production. So that's thank you from my side. And then I'm happy to take the questions after the second presentation in the plenum. So thank you.
Thank you so much, Manuel. It's an excellent presentation. Give us different perspective of beekeeping in your part of the world. The question about when the beekeepers have time to adjust quickly, and do they move hives? Do they do some management different to cope with this kind of changes of the weather and limited time to do the job?
Yeah, so it's particularly, it's not so time consuming when they decide where to move their hives, because they have to do that anyway. They're kind of all packed and set and they're ready to go. And now they just have to make the decision where to go to, for example. And then this can be very helpful, because before they had no idea how the weather will be down at the coast or how the weather will be up in the mountains. But now it gives them a pretty good indication on where the better nectar flow is to be expected. So that was the thing that was most useful for, and also in spring preparations, to anticipate when the season will start, when the bloom will start, when to get the hives ready for the upcoming season. So that was the main things they used it for. Yeah.
You do also transportation of hives from one location to another?
Yeah. Yeah. So but it's a different scale here in Norway. So a commercial beekeeper in Norway can live of 300 hives. Because the honey prices here are quite high. So even if you sell your honey wholesale to the cooperative that distributes it, you still get about €8 per kilo. So I'm not sure what that is in Canadian dollars, maybe $12 per kilo of honey that we get when we sell to the cooperative. So we do not depend on having so many hives to make a living out of it. And then, of course, it's easier to take care of 300 hives than it is to take care of 3,000 hives with the same amount of time. Yeah.
I think some of the questions are in the chat, and we'll keep those ones for later on. And
Yeah.
we would, yeah. So, Geoff, are you ready for the presentation?
Yep, I'll just share my presentation here.
So our next speaker, actually, Geoff Wilson from Saskatchewan Agriculture. He's a provincial apiculturist, and he is going to give us a talk about the Tropilaelaps surveillance and beekeeper response plan in our part of the world. And I'll let Geoff take it from here, introduce himself, and give us some ideas about his experience and his latest experience with Tropilaelaps. Go ahead, Geoff.
Well, thank you for the opportunity to talk to you here today. So I am the provincial apiarist with Saskatchewan government, and I basically deal with everything with bees for the province. And most recently, I've had the opportunity to study and work with Tropilaelaps overseas in both Thailand and in the country of Georgia over at the edge of Europe. Today, I'm going to talk a bit about surveillance and response plans at various levels and what beekeepers can expect and how we are moving forward as a country for dealing with this potential pest. So first, what are Tropilaelaps? Tropilaelaps are a mite. They are somewhat related to Varroa, but they look substantially different. So here we have three different mites, all from Asia. So these are the three mites that are of concern from Asia that originate on Asian bees. The first we're all familiar with, we're pretty much dealing with right now is Varroa mite. This is the one that is causing us all the problems. And when we have high mortalities across the country, it's typically this mite that's causing the troubles. And then on the far right, we have Tropilaelaps. So this is the mite of concern. It's the mite that we're going to talk about today. And it is much smaller than Varroa. It's about a third of the size. And typically, it's just skinnier. And then in the middle, we have Varroa. So this Varroa looks halfway between the Tropilaelaps and the Varroa mite. And it doesn't seem to be causing as much trouble as Tropilaelaps and appears to be less threat to Apis mellifera. And it's not currently seeming to be spreading across the world in the same way Tropilaelaps is. So Tropilaelaps are spreading. They originate in Southeast Asia, so basically from India and through Thailand, Cambodia, Philippines, and so on. And so they're originating in this blue area here. They are on the move, and they have been confirmed present in China, South Korea, and of particular notice is this little bit of Russia over on the side over here and Georgia. They're confirmed in these countries, as well as just down here in Papua New Guinea. These, so they are confirmed, but they're suspected to be present. So anecdotal reports from different areas in the world, including Ukraine and Turkey. So these mites are spreading, have been spreading, and the rate they're spreading, especially west, seems to be increasing. So what are we worried about? Well, we don't have them here, and we've got a great protection, which are our oceans. So basically, we'd have to get them here through shipping of some sort. So either through importation, for example, packages or queens, or on a container ship. Both are potentially viable routes for importation. And when we look at the importation of bees, we get two methods of importation, either queens or packages. Both can be considered a risk And I actually think that the queen importation is probably a higher risk than package importation. That's to do with the life cycle. Basically, it's fewer bees, but Tropilaelaps mites aren't known to live that long away from brood. So when we take packages, we typically get them shipped to Canada. They get shaken onto empty frames, and then it takes time for the queen to get accepted and laying eggs. So it's got a longer brood break, which will help to potentially reduce the number of mites that could infest a colony. So yes, still a risk, but I think it's less risk than the actual queens, which we take a queen from a nuke, put it in a cage, and it can be immediately shipped to a beekeeper where it's introduced into a colony that typically has brood already. So the mite spends a lot less time away from the brood, so potentially giving it a better chance of survival. And the other option is container ships. So yeah, these container ships do take time to cross the oceans, but just recently we had a case of a ship coming from India, stopping in Oman, going around the south coast of South Africa, and on its way to New Jersey. This was last summer, and about 3,600 miles off the coast of New Jersey, so kind of still out in the middle of the Atlantic. They found a swarm of bees, Apis dorsata, and this swarm of bees actually had Tropilaelaps. So if that container got to North America, it could potentially have introduced Tropilaelaps to here. Saying that, it was discovered and destroyed, so the port authorities and everybody did their jobs and was very responsible in dealing with that situation. So why could this be worse than Varroa? I won't say will at this point because it's all hypothetical. We don't know what will happen when it gets here. So Tropilaelaps and Varroa destructor somewhat act similarly. So they are both brood pests. They both develop on the brood, and they go through their development process on the larva and pupa. So at about day 7, I'll start with Varroa. The Varroa enters the cell and starts to reproduce. On day 10, the first egg is laid, and it's a male. And then eggs are laid every day or two, and basically they complete their reproduction inside the cell. The male will mate with the females once they mature, and they basically come out. So we have very incestuous relationship with Varroa. Typically, we get 1 or 2 potential mites. Most often, 1 daughter mite is coming out of the Varroa cell in Varroa reproduction. With Tropilaelaps, we get the mite invade the cell on day 8, and the first egg is laid day 10, and then 1 egg every day after that. Now, there's no sex differentiation that's known of currently, so it could be either male or female throughout. So we're likely getting 2 males and 2 females through this process. And the other neat thing about this pest is all of the mites mature in this development. So we get more mites coming out of the Tropilaelaps. And then in both cases, the mites emerge on day 21, and if it's drones, on day 24. So we get a higher number of successful mites emerging from the cells, but it's also sped up in the process of development because Varroa mites, like a dispersal period, used to be called phoretic period of 5 to 11 days. So the mites like to hang out on the adults for 5 to 11 days. With Tropilaelaps, the best guess is that the mites are are on the adults for between half a day to 2 days before they reinfest. So much shorter phoretic or dispersal period. When we were actively working with them, when we were in Georgia, we were there for about 3 weeks working with the Tropilaelaps, and what we saw was the Tropilaelaps mites seemed to be doubling every probably 11 or 12 days. So very, very fast. When we compare that with Varroa, it's doubling probably about every 28 days. So more than double the time to double, basically. Now, this mite does some serious damage to bees when it's out of control. The symptoms look very similar to Varroa damage. We end up with mites with deformed wing virus, and also the brood gets spotty. This is very typical of high mite infestations that's associated with Tropilaelaps or Varroa mite. So kind of indistinguishable between the two mites. What you will see more often with Tropilaelaps over Varroa is actual feeding damage from the mites. In this case, these mites, this was pulled out of a cell, and this feeding damage caused a truncated abdomen. So that's basically the abdomen's half the size of what it should be. And here on this larva, you'll see feeding sites, multiple feeding sites caused by the Tropilaelaps feeding on the mites, on the larva. You don't see this nearly as much with Varroa, and typically Varroa will have one or very few feeding sites, while Tropilaelaps will have multiple feeding sites, so causing much more actual damage to the colonies. Now, when we were, the person I was working with there actually had some clean colonies, never been exposed to Tropilaelaps before, and infested them with approximately 10 mites per colony. And he was saying within 4 months, if he didn't have an intervention, the colonies would be dead. When we compare that to initial infestations with Varroa, we were talking about 18 months. So this is a much faster initial invasion to potential collapse of the colonies. So yes, there's a potential for very serious situation with these mites. So what do we need to do? Well, one, we shouldn't get too worried about this. First, it's not here. And second, I told you the potential, and I don't think it's going to live up to the potential. I'll get into that in a little bit, a few slides from now. But first, we need to know what we're looking for and how we're looking for it. And hopefully everybody has fast enough connection that this video works. This is by far the best in-field surveillance technique. This is rapid brood decapping. It has a bunch of advantages in that we don't destroy brood, we don't destroy frames. We basically use hair removal strips, so depilation strips for removing hair from legs or body parts, and we push it down and we pull off the strip, and then you see the mites running around, and you just look for mites. The uncovered pupa actually will either be capped by the bees, and if they're not capped by the bees, they will continue to grow. Very effective, very fast. You saw real time how fast that was. It takes about 45 seconds to do the whole test, and basically it's 90% chance of finding it if it is there, according to the studies that have been done. So very effective, very cheap, not damaging anything. So really nice test for beekeepers to do if you're interested in surveilling your own colonies. The other one that is also effective for beekeepers or for researchers or whatever level is brood examination. So this is very time consuming, but very accurate. If you want to know what the actual infestation rate is right now, this is the only test out there. And basically what you're doing is you're just pulling out the pupa. This is a 100-cell rhomboid So it guarantees you get 100 cell in this here, and you just pull and you count the number of infested versus non-infested to give you an actual infestation rate. This is very accurate. But it's very time consuming. Everybody thinks about sticky boards as a potential solution for monitoring. It's not going to work very well. These things are tiny. At about a third of the size, they are difficult to see. If you have any difficulties at all finding varroa mites on a sticky board, you're going to have severe troubles with Tropilaelaps. So this is under magnification, and here we are counting the mites with a cell phone with a clip that does a 20 times magnification plus the magnification of the cell phone. Basically, when I was in Thailand working with a English inspector, we were counting sticky boards for Tropilaelaps. I counted one and I was proud. I had about 12 on it and I found all 12. He was working on his. He found 6, and this is, severe, looking hard, very hard. We traded sticky boards. He found 6 more on mine. I found 3 more on his. We've both counted a lot of sticky boards, had a lot of experience. They are going to be missed if you're relying on sticky boards to find them. The other surveillance method, PCR, is definitely an option. It's definitely improving as an option, and it definitely will play a role in the future. However, as a beekeeper and beekeeper level, this is probably an expensive way to go. Current estimate is about $25, $30 per sample for PCR. So yeah, very effective, good potential. But when you count the rapid brood decapping as about 30 cents per colony or 50 cents per colony versus PCR at about $30 a colony, there's a big difference. So there's another method, bump method. It was one of the first methods out there. I don't like this method as much. It can be effective, but it can damage both the brood and the frames. So yeah, it is a field test that can be done, but it's not nearly as effective. It's not nearly as good because of potential damage to the bees and to the actual equipment. And we always push alcohol shake for varroa testing. However, it doesn't work that great for Tropilaelaps. Tropilaelaps are light and they're small. They're hard to see in the container. They also float, making them very, very difficult to count. So yes, keep up your alcohol shakes for varroa, but for Tropilaelaps, it's not going to work as well. There are no registered treatments right now, but we do know we have products already registered in North America for varroa that work very well. So we're testing, this is FormaPro and mite white pads and mite gone pads. We were testing these in Georgia, and we found that they all can work. And depending on the concentrations they put them on, you can, get excellent results. They actually respond better to Tropilaelaps, or work better on Tropilaelaps than they do varroa. So if you put on enough formic acid to kill your varroa, your Tropilaelaps are long dead. So very, very good option. It's already here. It will take time to register them. But yeah, it should be easier because they're already registered for a different critter on beehives. Other options could be oxalic acid. Problem with oxalic acid is these mites like to really hide under the cappings, so they're really hard to reach with oxalic acid. So basically, oxalic acid is probably only a real option when there's no brood present, so combined with the brood breaker right before winter or something like that. Everything else out there doesn't work very well, or there's limited likelihood of registration. So in Thailand and places like that, they're using various products and they are working there. However, this is a flumethrin strip. that's placed in the bottom board of the colony, and it's left there year round. So that we're never going to get a product like flumethrin that we can apply year round inside a colony during honey flow or whatever. And then this red can here is a spray can of Amatraz that they just spray right on the bottom board. So that's not going to be an option in North America, or I highly doubt that'll be an option in North America. So these kind of options won't work. And when we try things like Apivar strips, there's limited success in making them work for Tropilaelaps. Will things be worked on? Absolutely. And we may get products that work along these lines, but these will take time to make sure that they fit our beekeeping conditions and food production requirements. On a bright side, there are biological controls that work very well. One major example is queen caging or brood removal. So on the left, we have queen caging in Thailand, and what they do is they put the queen in this cage, leave it there in the colony, in the cage for 3 weeks, and then release her, and giving a nice brood break. And often they'll combine that with an oxalic acid treatment. Or we have this Georgian cage, same thing. And so they're establishing a brood break, which doesn't allow the mites to reproduce. And because they require brood so much, a lot of them die in the meantime. So it makes it a very effective brood control option, mite control option. We have a great advantage here on this brood break. It's winter. So winter may be really good for us in helping to control these mites, providing a natural break from the brood and natural mite control option. So yeah, winter, I know we're getting sick of it right now. It's minus 17 this morning and a snowstorm outside my window first thing. And I was pretty sick of winter, but it may really help us with things like Tropilaelaps. So what's going on? Basically, there's a lot of work happening on Tropilaelaps preparedness in the background. So you may not be seeing it right up front, but there's a lot of people working together to come up with a potential response plan in the event of the invasion, or helping to keep the mite out. This is being headed by the Canadian Honey Council currently. So they're doing a lot of the activity to coordinate a lot of the responses, but there's many different partners. There's Canadian Border Services Agency, provincial governments, Pest Management Regulatory Agency, Canadian Food Inspection Agency, and bee health suppliers and researchers. So the Canadian Honey Council is actually leading the initiative for Tropilaelaps response. They're doing a lot of the coordination and ensuring the final action plan basically respects the needs of all Canadian beekeepers. And then as part of this group, we have the industry or provincial associations. So they're coordinating with the Canadian Honey Council on the national industry response, and they work with the provincial governments on provincial level responses and provide many educational opportunities for beekeepers. For example, webinars just like this one here. Now, as a subset of this, we actually have beekeepers' role. And the beekeeper's role is to make sure that they get educated and they are looking and on the lookout for the mites or anything like that. So yeah, beekeepers do have a role in what we'll call the industry level response. The Canadian Food Inspection Agency also has a big role. Basically, they regulate the importation requirements for importing honeybees to Canada. They ensure that the countries exporting honeybees to Canada are certified, they're Tropilaelaps free, and they're working with their counterparts across the world to ensure that this happens. They're closely monitoring the global progression of the mite and are in continuous continuous communication with other countries to determine their health status. Canadian Border Services Agency, you've seen this picture before. So you know that situation where the container ship was found to have Apis dorsata with the Tropilaelaps. In Canada, that's up to the Canadian Border Services Agency to deal with. So they are border and port controls and inspections. They're also responsible for anything originally coming into the country and dealing with that. So CHC has a big role. The other probably biggest role is your provincial governments. So the provincial governments are making provincial level policy and procedure plans. So these entail government level surveillance, the response after the arrival. So if it gets into a province, what happens? This might include, it does not definitely include, but it might include quarantine, containment, treatment, and potentially destruction. So you'll have to contact your own province directly to see what's going to happen. And these procedures and plans or policy and plans are in development. So they're currently under evaluation. And they're also dealing with education and consulting with your provincial beekeeping groups. Researchers and bee health suppliers, hopefully they're looking at new products and registering products for mite control. So we do know formic and oxalic have great potential, but we also need to identify other compounds that will work and other methods of applications. And we have the PMRA, basically, they are responsible for registering products. The nice thing is most of the products will be a label extension of varroa control products, making it a faster process because everybody's there. There's a few things that are working very well. One is regional collaborations that are happening, or international collaborations that are happening. We've got great buy-in with between Fire Sciences, Apiary Inspectors of America, Auburn University, Project Apis M. All of these have great content out there. If you're looking for content to increase your education on Tropilaelaps, you can look up any of these and they have got some really good resources. The other thing that's working very well is the National Preparation Framework. So everybody's working together nicely, coming up with these plans, and we've had excellent participation by stakeholders. So it's working very, very nicely. We are facing problems. One of the first problems is actually science. This is a relatively unknown mite. There are thousands and thousands of research papers on varroa, and I don't even think there's 200 on Tropilaelaps yet. So the science is rapidly changing, and it's changing very quickly. The science we know about this 5 years from now will look nothing like what we know right now. There'll be so much more advancement in the work on Tropilaelaps. The other problem we have is these mites are not in North America. And the beekeeping conditions and the bees themselves, yes, they're Apis mellifera, but the colonies don't really represent what's going on in North America. So, and when we were in Thailand, I was at Chiang Mai University where we were doing some work. This was the average colony in Thailand. So you can see it's about a 5-frame nuke size, even though there's 6 frames in here. So very, very weak. And this was average. Does not represent a full-sized honey production colony that we're used to in North America or Europe. However, as the mite progresses through Europe, we'll get better results. So in the country of Georgia, this was the size of a colony we were working with. So this is a 12-frame Dadant hive, and it was just in October, and you can see it's nice and full and very similar to what we would have here. So for those of you who don't know about Dadant sizes, a Dadant box is about 1.5 standard Landstroths. So much more similar to our conditions. We also have a fear of the unknown happening. No one really knows what will happen when and if Tropilaelaps arrives in North America. We can get a good idea from what's happening in other places. But really, quite frankly, it's all guesses until or if it gets here. There's also a lot of unjustified accusations that Canada is not taking any action, and we're seeing that online or in various meetings across North America. We're actually doing a lot, and we're at least as far ahead as what's happening in the United States. One of the things you can tell that there's a lot of no one will know, and everybody's concerned is when I was in both Georgia and Thailand, I took over the SBDC Facebook page and posted pretty much daily. And we ended up with a 9,360% increase in traffic in 28 days. So there's a lot of desire to know what's going on. We need to get this education out there. So what will happen? This is all speculation. Please don't hold me to this because, quite frankly, we don't know and I don't know. But it'll go one of two ways. First way is it may not be a big problem for Canadians, for Canada's beekeeping. There's a couple reasons for that. One, the mite is so aggressive, it will kill the colonies over winter before it can spread very far. So this thing is so bad that it kills itself off because in some parts of the country, we get 6 months of winter, which is 2 months longer than the average time to kill a colony. So it kills itself off because it's too aggressive. I think that's not going to be the case. I personally think that the mite doesn't like brood breaks, and it'll be controlled by our winter conditions. And we can see some evidence of this because when you look into areas like Beijing or Seoul, Korea, Tropilaelaps is there. They deal with it, but they say Varroa is a worse pest to deal with versus when you're in a more southerly area where they say the Tropilaelaps is by far worse than Varroa. So I think our northern climates will help. Saying that, repeated introductions in either of these two situations, repeated introductions from other areas could cause large annual problems because it only takes a couple mites to grow rapidly to take down a colony. So continual introductions from either queens or packages would potentially cause huge problems. The other way it could go is this could be a huge problem for Canadian and prairie beekeepers. Basically, if our winter doesn't help to control, we will be having to treat our colonies approximately every 2 months. And wherever we are in Canada, a couple exceptions maybe in Vancouver or southwestern Ontario, it might be possible to get in every 2 months to treat your bees, but it's basically impossible for most of Canada. So this would cause huge problems. For the North American context, it will definitely be a problem in warmer areas. So if we get into southern US, it's going to be there. It should do well. And it will require treatment every 2 months. So I think the southern North American beekeepers could have a huge problem with this, potential problem with this mite if it arrives. The other issue is a huge learning curve. We're barely figuring out Varroa right now, as you can see by our elevated mortalities over the past few years. And this is another new mite that could potentially throw some more problems our way. So my thoughts. One, keep this pest out for as long as possible, but be prepared for its arrival. Don't worry about this mite. Just get some education, kind of know what you're looking for, have some ideas what may happen when it comes, but definitely concentrate on your varroa. Deal with the pests we have. Deal with the things you can control. So deal with your beekeeping the way you have done. Concentrate on making sure you have healthy colonies and don't get too excited or upset about Tropilaelaps at this point. And yeah, I'll pass it over to the last slide, which is question period.
Informative information here about the strawberry. And I like the fact when he said we should not really take out the spotlight from the raw mates. We have to deal with it first, and good information to be prepared for trophy. Question period here, and just to organize our questions, there are lots of questions being already written in the chat. Some addressed to Geoff, others addressed to Manuel. To give Geoff a chance to read the questions so he can get himself ready to answer some of those ones. I'll start with Manuel, and if you check through the chat and you can read the question and answer it, you will always provide some time between the question and the answer for our French speaker to translate the question. And after you do your answer, actually, you can make some stops for the French speaker to translate. This is a bilingual seminar, and that will help us to address all the audience, English and French speakers. Thank you so much. And Manuel, that's your question first.
Yes, thank you. I'm checking them right now. Well, there was one asking, how do those long-term forecasts take into account the jet stream?
Donc, la question est comment est-ce que les prévisions météorologiques prennent en compte le jet stream donc de la mer, si je ne me trompe pas?
Yeah, so the jet stream is basically a fundamental part of the models because up in these northern latitudes that we are in Norway or you are in Canada, it's basically the circumpolar jet streams that divide the Arctic air from the milder air over the continent, over Europe. And depending on how strong they are, they will curve out further south or further up north. And that can basically funnel cold air down into Canada or Norway or push the warm air back up. So in these northern areas, the jet streams are one of the main drivers for the temperature that we have in summertime.
Donc, la force du jet stream, donc du mouvement marin qu'il y a dans l'océan, va modifier, en fait, va avoir un très grand impact sur les prévisions météorologiques parce que tout dépendant de sa force, il va modifier, en fait, l'air ou la montée de l'air vers le nord. En Europe, ça va ramener de l'air chaud plus haut vers le nord, alors qu'au Canada, par exemple, ça va descendre de l'air froid plus au sud de l'Amérique du Nord. Donc, la force va vraiment influencer les prévisions météorologiques.
Yes, I'm in Canada, Edmonton, and we're having an extended winter. Spring is delayed and not expected till late April. Once we open up when temperatures are good, how do you suggest we go about it?
Dans le fond, where are those questions, guys? They're higher up in the chat.
Yeah.
Yeah, they're very far up. Yeah.
At
It's
about
6:33.
11:33, according to the time.
Yeah.
Oh, can I see the time? Oh, yeah. Oh, shit. I need to bring that up, but I don't seem to be able to. So you're going to have to repeat the question again.
I will repeat it in two
Yeah.
steps. We'll take it in
Yeah.
two, then it's easier. So I'm in Canada, Edmonton, and we are having an extended winter. Spring is delayed and not expected by April.
Donc, je suis au Canada, à Edmonton, puis je m'attends à ce que le printemps soit retardé.
Once we open up when temperatures are good, how do you suggest we go about it?
Quand on va ouvrir les ruches, tout dépendant des températures, quelles sont tes suggestions pour la façon dont on va procéder à l'ouverture de nos ruches?
Yeah, well, I'm not quite sure how you do it in North America and what an extended winter for you means. For us, where I'm in Bergen, that a longer winter already means positive temperatures, like 4 or 5 degrees plus. And in this case, we start stimulus feeding them with liquid food to stimulate the queen to start breeding in time. So we're a bit ahead when the actual spring comes.
Okay, Geoff,
Dans le fond, je suis...
hold on. Sorry, go ahead, Maggie. Go ahead, finish.
OK. Je ne suis pas certain si je peux comparer ce qu'on fait en Europe avec le Canada. Par contre, nous, en Europe, ça veut dire qu'on va quand même avoir des températures de 5 à 6 degrés Celsius quand on parle d'un printemps tardif. Donc, la première chose que je vais faire, ça va être vraiment d'aller valider mes ruches et de les stimuler pour que les graines commencent à pondre le plus tôt possible.
Jeff, maybe you can add a little bit here because you are in Saskatchewan, next door to Edmonton area.
Sure, we were actually a little colder than Edmonton typically, so it's even more true here. Basically, if you're in Edmonton and you want to work your bees in April, go ahead and work them. Just wrap them again and leave them wrapped if you're a small scale beekeeper in particular, and leave them in their wrappings and rewrap them until mid-May, early May, and it just ensures that the colonies are, not are allowed to grow without damaging or brood through freeze kill. I'm
La
going to let
suggestion,
Maggie.
yeah. La suggestion de Geoff, c'est dans le fond, dans le secteur d'Edmonton, c'est très possible de travailler les ruches en avril. Il s'agit simplement de les ouvrir, de faire attention aux températures, mais de les emballer de nouveau jusqu'en mai pour vraiment conserver la chaleur au niveau des grappes et des ruches, parce que si on les déballe trop vite, ils vont subir plus fortement les variations de température gel-dégel qu'il y a encore à cette période-là de l'année. Et donc, on peut se ramasser avec du couvain qui ne sera pas couvert par la grappe si les températures descendent trop bas. Et donc, ce qui tuerait en fait une partie du couvain qu'on essaie d'élever le plus tôt possible.
Question for Geoff. You can see it here in the chat from Ian Grant.
Have there been studies / research that indicates there is a greater probability of spreading Tropilaelaps via queens versus packages? It seems to me that it would be greater in the latter, especially if there's capped brood in packages.
Est-ce qu'il y a des études qui montrent qu'il y a une plus grande possibilité de dissémination du Tropilaelaps par les reines versus par les nucléi ou les paquets d'abeilles? Selon la personne qui pose la question, selon lui, les nucléi seraient probablement une plus grande source de dissémination à cause de la présence de couvains.
So that statement is speculation by me. There has not been a study to compare the relative risk of packages versus queens. And the one thing I will state is when I say packages, I mean it's coming just bees and a queen with no brood. So the nucleus would have the brood, and in this case, packages have no brood. So I'm going to leave it there so Maggie can translate that, and then I'm going to carry on again.
Donc, Geoff mentionne que c'est seulement pour le moment des spéculations, des hypothèses qu'il fait par rapport à la transmission du Tropilaelaps par les reines versus les paquets d'abeilles ou les nuques. Il faut préciser dans le cas où Geoff faisait sa présentation qu'il parle vraiment de paquets d'abeilles. Donc, le paquet d'abeilles, ça veut dire que c'est seulement les abeilles, il n'y a pas de présence de couvain à l'intérieur du paquet d'abeilles.
So when we're dealing with packages versus nucleus colonies, that would be a completely different answer. So the nucleus colonies would have a higher chance of the highest chance of the three of importing the Tropilaelaps, but we cannot import nucleus colonies internationally, and that's the only way we're getting it into the country. So that's what I focused on.
Donc, si la question aurait été plutôt entre la possibilité d'importation du Tropilaelaps entre un paquet d'abeilles et un nucléi, la question aurait été complètement différente. Parce que, dans le fond, le paquet d'abeilles, comme on l'a dit un peu plus tôt, n'a pas de couvain, alors que le nucléi a du couvain dans lequel le Tropilaelaps peut se reproduire. Et actuellement, au Canada, ce n'est pas possible d'importer des nucléi contenant du couvain. C'est seulement possible d'importer des paquets d'abeilles sans couvain. Donc, le risque est moins élevé pour un paquet d'abeilles de transmettre le Tropilaelaps que pour un nucléi dans lequel il y aurait du couvain.
Manuel, Karen Pedersen question at 11:44.
My understanding is that the jet stream creates a lot of our variability, creating bubbles. So if Norway is more influenced by the Gulf Stream, are those long-term forecasts more dependable than a large landmass?
Donc, est-ce que le Gulf Stream aurait un impact qui est plus important au niveau des températures et des prévisions météorologiques comparativement à un territoire, un très grand territoire là, qui n'est pas marin, mais vraiment de la terre ferme?
I would say that there is not a very big difference, because in this case it is very connected. Like the form of stream of America also will depend to a certain degree on how the ghost, not the form of the jet stream will also depend on how it looks over North Atlantic, which influences us. So it's very connected in a way. So you can't really say that it's in Canada more dependable than in Norway or the other way around.
En gros, il n'y a pas vraiment de différence au niveau des prévisions entre la terre ferme, la masse de terre ferme ou par rapport au Gulf Stream, parce que les deux, en fait, sont très dépendants l'une de l'autre. Donc, vraiment, les deux vont influencer la température de l'air, ce qui va impacter là, la météorologie et les prévisions météorologiques.
Thank you.
And if I can add to that,
yeah, go ahead.
Everybody knows El Nino and La Nina, the phenomenon that we have in the South Pacific, but we have something similar and also an oscillation in the North Atlantic that's called the North Atlantic Oscillation, and that's basically a similar thing happening all over the North Atlantic between Canada and Europe, and that's the main driver for this jet stream. So it's very close and connected, just to add to that.
On connaît tous le El Niño et le El Niña dans le sud, qui ont vraiment un impact majeur sur les conditions climatiques là, au niveau de l'Amérique du Sud. Nous, on a quelque chose de similaire dans la partie nord. Ça s'appelle l'oscillation nord-atlantique, qui est vraiment qui impacte énormément là, les températures au niveau de l'Europe et de l'Amérique du Nord.
There's a
Thank
question.
you,
Can you
Geoff. Yeah, go ahead.
replay that? I assume that's my video on rapid brood decapping. Let's see here.
Okay. There's a question before that, like, I can take a picture on the board or of the board with my phone and count later on Mac.
Okay, am I sharing this screen here?
Yeah,
Okay, there we go.
full screen, if you don't mind.
No, I can't do that easily right now. Sorry.
Okay.
So basically, he's taking the hair removal strip, pushing it down into the frame, onto the cappings, pulling it off. This is real time, and we're dealing with one of the inventors of it. That's Irakli Janeshia and Maggie Gill in the video, and I'm taking the video. And here you can see the mites running around on the frame. So very, very quick. This is absolutely real time. There's no faking this. It's just taking a frame out, pushing it down. Other things don't work. This is the only thing that's been found to work. People ask about duct tape. Apparently, duct tape does not work.
Do you
Donc,
recommend
ce qu'on voit
beekeepers?
ici, you want me to translate?
Sure.
Yep, go ahead.
Donc, ce qu'on voit ici, c'est vraiment là, on colle dans le fond une languette à épiler sur les opercules du cadre et là, on va tirer très rapidement pour arracher les opercules. Ça va déranger le Tropilaelaps qui va sortir de la cellule. Donc, c'est ce qu'on voit à l'instant. On colle la languette, puis on épile les opercules. Les Tropilaelaps vont sortir et vont se mettre à courir sur la cire. C'est là qu'on va pouvoir détecter la présence ou non du Tropilaelaps. Ça, c'est vraiment en temps réel, cette vidéo-là. Donc, on voit à quelle vitesse les Tropilaelaps courent sur le cadre. Puis, c'est vraiment, il y a pas ils n'ont pas trouvé encore d'autres choses de très intéressant pour procéder à cette technique-là. Même le duct tape gris ne fonctionne pas aussi bien que cette languette-là à épiler.
Yep. Do you recommend beekeepers to do some random inspection for some hives?
That would be absolutely fine. So it'd be not a problem if they want to do the test, if for nothing else, to practice in case it comes. But yeah, it wouldn't hurt if you want to do some of this testing.
La question était, est-ce que les apiculteurs canadiens devraient commencer à faire des tests au hasard sur leur ruche? Geoff a répondu que, on peut commencer quand on veut à faire des tests afin de valider la présence ou non du Tropilaelaps. À la limite, ce que ça va nous permettre de faire, c'est de se pratiquer et de vraiment valider qu'on est capable de mettre en place la technique et de façon adéquate.
Do you have the next one at 11:52? And actually, that was from myself.
There was one about taking a picture. Can I take a picture of the board with my phone and count it later on a Mac? Easier to see. You need, it's very difficult. You need about a 10 times magnification to be able to tell the difference between a fleck of wax capping and the actual Tropilaelaps. So even a picture, it's very difficult. You'd have to do some significant magnification.
La question était, est-ce que je pourrais prendre une photo du plateau pour ensuite utiliser cette photo-là sur mon ordinateur pour valider ou compter la quantité de Tropilaelaps présents? La réponse était vraiment que c'est très difficile parce que ça prend un zoom de 10x pour être capable vraiment d'aller chercher le Tropilaelaps et être capable de faire la différence entre le Tropilaelaps et une petite particule de cire qui pourrait se retrouver sur le plateau.
sociality structure of bee colony mediate vulnerability to climate change.
Was that translated now?
No, go ahead.
You're going to have to reread that to me, please, Meta. I did not understand.
Okay, it's at 11:52. Go ahead, Manuel.
Let's translate first.
But what's the question?
I can read it out. How does the social structure of bee colonies mediate the vulnerability to climate change? And how might climate change impact social organization in bees?
So how does the social structure of the colony impact or tolerate the
or
temperature,
mediate?
please?
So how does the social structure of the bee colony influence the vulnerability to climate change, maybe? And the
Comment
second,
est-ce que la structure de la colonie peut influencer ou réduire l'impact des changements climatiques sur cette dite colonie? And
the second part is how might climate change impact the social organization in bees?
comment est-ce que les changements climatiques pourraient vraiment influencer ou impacter la structure de la colonie en tant que telle?
So this is a bit of a different topic because it goes more into the bee biology, whereas we are working more with with beekeeping practices, like what can the beekeepers do? And I think it's important to differentiate between the direct impact of climate change on the beehives, like temperature, floods, humidity, but we see the main impact of climate change is actually indirect through the environment, through changing vegetation, through changing land use and stuff around that. So how that will influence the social dynamics of bees, I think that will be a long-term process until that really kicks in.
Donc, c'est très difficile à évaluer exactement quels seront les impacts parce qu'il y a deux types d'impacts, donc les impacts directs et les impacts indirects qui vont avoir lieu sur la ruche. Quand on parle d'impact direct, on parle vraiment de la température, par exemple, de l'humidité, de la quantité de pluie. Ça, c'est des impacts directs qui vont influencer la colonie, qui vont faire qu'elle va se mettre en grappe ou non, etc. Alors qu'on a aussi, en deuxième lieu, les impacts indirects qui sont l'environnement, donc la présence de certaines fleurs, la floraison, à quel moment de l'année va avoir lieu. Encore une fois, là, tout ce qui est au niveau de l'environnement de la ruche.
Geoff, you have the next one?
Does Varroa and Tropy compete in the same colony? And will one species displace the other?
Est-ce que le varroa et le Tropilaelaps se compétitionnent l'un l'autre dans la même colonie et est-ce qu'à moyen long terme, il y a un des deux parasites qui va prendre le dessus sur l'autre parasite pour infester les ruches?
So, working in Georgia, we were working on the co-infested colonies. I must emphasize again, this is the country of Georgia, not the state of Georgia, where both Tropilaelaps and Varroa were in the colonies. And we were working on pulling out pupa. And in highly infested colonies, we would find both Varroa and Tropilaelaps in the same cell, both reproducing successfully.
Donc, lorsque j'étais en Georgie, on a vraiment travaillé sur des colonies qui étaient infestées autant par le varroa que le Tropilaelaps. Et lors de nos expériences de sortie des larves, des pupes, des cellules, on en trouvait qui étaient fréquemment infestés par les deux parasites en même temps, donc le varroa et le Tropilaelaps. Et les deux parasites dans la même cellule réussissaient très bien à se reproduire en même temps.
It's a new infestation in Georgia. Time will tell if one outcompetes the other, but right now it doesn't appear that it appears that both will be fine.
Le Tropilaelaps, c'est vraiment une nouvelle infestation au niveau de la Georgie. Ça va vraiment être le temps qui va nous permettre de déterminer s'il y a un des deux parasites qui va pouvoir prendre le dessus sur l'autre. Pour le moment, on n'est pas capable de confirmer ou non si le varroa ou le Tropilaelaps va prendre le dessus.
Geoff, one more here from Kerry Clark.
It's clear that trope survive on mega apis, so that would be the large apis species like Apis dorsata, without brood, weeks in migration. Any ideas how? The answer to that scientifically is no. The best guess, and people are just guessing, starting to do projects on this right now, is that there's some sort of cue the Tropilaelaps are picking up from the bees that are getting ready to swarm or leave, and they are hardening off or finding some way to survive. Same was true with that swarm that landed on the ship coming around South Africa. It was basically on the ship for 15 to 20 days minimum. And that is significantly longer than what the best estimates of how long Tropilaelaps survive without brood, which is 8 days. So basically, that question is a wonderful question that needs further study. But probably picking up a cue and changing some sort of physiology of the mite or some sort of behavioral change in the mite.
I think we are running over time here. We are going to take one more questions. The rest of the questions, which is in the chat, will be answered as part of the recorded session. So just to respect the time for the people who are already attending from other parts of the world. So the last question here for you, another one, Geoff, can Amiflex be used for trophy control? It is a gel and distributed inside the hive. It's different from Epivar strips.
I believe that was being studied in Korea and by Geoff Pettis, and I think he had some positive results on that one. So yeah, there is potential that it might work for Tropilaelaps.
Donc, la question, c'était est-ce que le gel Amiflex peut fonctionner contre le Tropilaelaps? Geoff semble dire que oui, il y a des tests qui ont été faits aux États-Unis, mais on attend toujours là, les confirmations officielles.
So thank you so much, everybody, for attending this seminar. And I'd like to acknowledge all the work done by the Canadian Tech Transfer team and the Canadian Honey Council and the contribution of Véto Pharma to allow us to do this on their platform, and also carry a lots of work behind the scene to make this project possible. The committee which worked in that project at this time, it was Matthew Poloniski from Manitoba, Andrew Bear from New Brunswick, Maggie Lemont from Quebec, and Martine Bernier from Quebec, and Miguel Rodriguez, Véto Pharma, and myself, Matt Hartness, and we hope we can repeat this kind of webinar in another session or two, depends on subjects, what you need. We would like to get feedback from you guys. If you are interested in certain subjects, please send email to Miguel or myself, and we will look at these ones to consider for our future webinar. Thanks again, and have a wonderful day wherever you are at, and we will see you again. Thank you.
Merci beaucoup à tous.